Alright, we've been through and seen how to make a different sort of a table, and now we're looking at how to represent that in a line graph. Now, the easiest option for us to use is to use a scatter plot. Now, a scatter plot is good because we know that our results aren't really all in one spot. We saw from the table that the values are different, they have a bit of a difference in them. So a scatter plot best represents what we actually found out. And then eventually we can go and put together with that scatter plot a nice little trend line which shows us the general pattern in our plot. Alright, so what we're going to do is we're going to look at the situation we had last time where we had the time it takes for a 0.5 gram piece of magnesium to react with acid of different concentration. Now we need to go back to our table from last time, so let's go and have a look at it now. Well, doing a scatter plot is very, very similar to doing any sort of a graph we did before. Like our last graph, we basically put a highlight around what we were going to measure and then we work from there. So let's just do that. Right, we start off and we highlight the whole lot. We highlight the whole table and then we duck up to insert and we put in the chart. Now, the option of charts is quite good, but as I said, the scatter plot really shows us how our data between the magnesium and the time and the concentration is all related. So let's have a look, and we know that it does vary. Of course, it's shown rather clearly in the table. So let's use this scatter chart and we end up with this lovely plot like that. Right, so as with always, we go up to customize and let's fix this up. So our chart title could be something beautiful like the time taken for 0.5 grams of magnesium, Mg for magnesium, to fully react in acids of different concentrations. Alright, so let's put that in there. That looks okay. I've got a bit of a editing to do. That looks better. Right, now as with our other chart, we of course then have to tell us what we're doing. So in the horizontal this time, we have concentration of acid. Now if we know the acid we've used, we should put that in. So if it was hydrochloric acid, we put HCl in there. And we know this is in either molarity or moles per dm cubed. Now I would expect molarity from years 7, 8 and 9 perhaps, and then from years 10 and above, mole per dm cubed would be good. And then if I go through and put the vertical axis in, it of course is the time taken for the full reaction. And that of course is measured in seconds. So now that's not that hard, is it? So we've done that, we put those in. Now at the moment this is only a scatter plot, and we can see that our scatter plot doesn't look like a straight line. So we can actually find right down the bottom here a thing called a trend line, and we have three options for a trend line. So if we look at what it would look like with a straight line. Now a trend line does not have to go through all points. It should go near them because we know that the real value will be close to the plot, but it will not necessarily be the plot point. Alright, now that one has too many differences, I think. So let's look at what other options we have. Now we have an exponential. Ooh, now that one looks like pretty close. So I'm thinking we might use that one. Alright, so if we use that one and say, OK, insert. Now there is our completed plot, all with the trend line and all nice and neatly labelled, fully labelled, showing complete mastery of this whole process. Alright, that would be really a good way of presenting things. Then all we do is we simply copy the whole lot and put it in our write-up, in our report. And that should be the way we should do it. Alright, I need you now to practice that, especially next time when you go and do your next activity in chemistry class.